Hello everyone, this is 5.1 video part 2. So we continue with derivative of e to the power of x. So let's look at example 3. So we are going to find f prime. Okay, part A, f of x equals e to the power of 5x. So exponent is a function of x. So when we get the derivative, we write f of x as it is first, so that gives us e to the power of 5x. Then we multiply this by the derivative of the exponent, so that gives us 5. So 5 e to the power of 5x is the answer. Let's look at B. F of x is e to the power of 3x squared minus 2x f prime. So again, we write it as it is. Then we multiply it by the derivative of the exponent. So we get 6x minus 2. 6x minus 2. Okay. So we can also write it as 6x minus 2. Doesn't matter. E to the power of 3x squared minus 2. Okay, let's look at C. Okay. So we're going to take the derivative of that. But as you see now, this is x squared, 3x squared times e to the power of 4x. Now we have to apply the product rule here, okay? X squared is multiplied by e to the power of 4x. So 3, I'm just going to keep it here. And then now I'm going to take the derivative of x squared times e to the power of 4x. Okay, so derivative of first, so 2x times the second plus derivative of second, so e to the power of 4x times derivative of the exponent 4 times the first, so x squared. So let's simplify this. So we get 2x e to the power of 4x plus 4x squared e to the power of 4x. Okay, so we see that 2x times e to the power of 4x is a common factor. So if we take it out, we get 6x e to the power of 4x, and that gives us 1 plus 2x for the second factor. Number 4, find the equation of the tangent to f of x equals e to the power of x divided by x squared, where x equals 2. Okay, so to get the equation of the tangent, first we need to get the slope of the tangent. To get the slope of the tangent, we need the first derivative. Okay, as you see now, we have a division here. We need to use a quotient rule. The derivative of numerator, e to the power of x, times the denominator, minus derivative of denominator, 2x, times numerator, over square of the denominator. So if we simplify this, we see that x and e to the power of x is a common factor. So we get x minus 2 here, and denominator is x to the power of 4. Okay, so to get the slope of the tangent at x equals 2, we need the value of the first derivative when x is 2. So we substitute 2 in here, and we see that 2 minus 2 gives you 0, so numerator is 0, so 0 over anything is 0, so we get 0. So looks like slope of the tangent at x equals 2 is 0. So then we need to write the equation y equals mx plus b. So we know that slope is 0, but looks like we need to get the b value. So let's remember, we need to substitute a point here. Okay, so we know that the x coordinate of the point is 2, but we need the y coordinate of the point. So let's substitute 2 in the original function to get the y coordinate of this point. So we get e squared over 4. Okay, then the point that we need to sub is 2 and e squared over 4. As you see, x becomes 0 anyway, so b is then e squared over 4. Then the equation of the tangent is y equals e squared over 4. Most of the time we will leave the exact value for the equation. Okay, so this is the answer. Let's look at example 5. Find the equation of the tangent to f of x equals 3 times e to the power of x, where x is ln 4. So similarly, first we are going to get the derivative. So derivative is 3 times derivative of e to the power of x is e to the power of x. So derivative is also e to the power of 3 times e to the power of x. Now we need the slope at ln 4. So we substitute ln 4 in this equation. Okay. So using the shortcut, we know that e to the power of ln 4 is 4. Okay. And again, if we, I need to remind it, e to the power of log base e of 4, right? This gives you 4. So okay, so we get 12 as the slope. Okay, then when we need to write the equation, we get 12x plus b in a x plus b form. So we need a point to sub, right? Okay, so again, we are given the x coordinate of the point. We need to calculate the y coordinate. So I'm going to sub in ln 4 in the original equation. So this gives us 3 times e to the power of ln 4. So because the derivative is the same, we already calculated that value and we get 12. So the point is then ln 4 and 12. Okay, so let's sub those points in. So we get 12 equals 12 times ln 4 plus b. Then b becomes 12 minus 12 ln 4. Then the equation of the tangent is 12x plus 12 minus 12 ln 4. And again, usually we just leave it in exact form. Okay, so this is your final answer. This is the equation of the tangent. Example 6. So we have a word problem here. The number n of bacteria in a culture at time t in hours is n of t 2000 times 5 plus e to the power of negative t over 5. What is the initial number of bacteria? So this is not even related to calculus. When they are asking for initial value, so we substitute 0 for t. Okay, so n of 0. So if we do that, 2000 5 plus e to the power of 0 over 5 gives you 0. So e to the power of 0 is 1, like any other power with 0. So you get 6 here, and we end up with 12,000 bacteria initially. Okay, B. Determine the rate of change in the number of bacteria at time t. Now they're asking for the derivative of the function. So n prime equals, so we are going to keep that coefficient 2000. We are going to take the derivative of this bracket. Derivative of 5 is 0. Derivative of e to the power of t over 5 is e to the power of t over 5 times negative 1 over 5. Then if we multiply 2000 and negative 1 over 5, we get negative 400 e to the power of t over 5. That is negative. Okay, that's B. C. How fast is the number of bacteria changing when t equals 2? The rate of change at 2. So we need to substitute that 2 in the derivative function. So we get negative 400 e to the power of negative 2 over 5. Now you can punch this in your calculator, and if you do that, you get negative 268 bacteria per hour. Okay, so that means that number of bacteria decreases, and then hourly, at that point, 268 bacteria. So D. Determine the largest number of bacteria during the interval t greater than or equal to 0 and less than or equal to 10. So let's remember how do we get absolute max and min. Okay, so what do? We substitute the and values of the interval in the function, and then we also get the zeros of the first derivative and sub also those values in the function and check which one is maximum or which one is minimum. In this case, we are looking for the maximum value. So we are going to substitute 0 in n function. Other endpoint is 10. Okay. We also need the zeros of the first derivative. First derivative is here. Okay. But if we want to make it equal to 0, so we get 0 equals e to the power of negative t over 5 from here, if you divide both sides by negative 400. But when you take the power of e so exponent can be anything, but actually you will never get 0 from here. If you can remember the graph we did for e to the power of x, so we said that it is always greater than 0. It is above the x-axis all the time. So this will actually never become a 0. So we don't get any zeros from the first derivative. Then to decide what is maximum, we can only check the end points of this interval. So when you substitute 0, we already calculated it with part A. So we get 12,000 bacteria. Okay, now we are going to substitute 10 in here. So we get 2005 plus e to the power of negative 2 over 5. So substitute 10, you get negative 2 here. Then if you calculate this, we end up with 10,271 bacteria. So looks like 12,000 is the greatest. Then we can say that maximum number of bacteria is 12,000. Okay, and that's happening when time is equal to 0. Now you can go your textbook and then do these textbook questions to practice.